Okay guys, welcome to another video for additional mathematics. Today we will be tackling quadratic expression and equations. Yep. Here I have compiled a list of challenging questions. Questions that will be worth more marks and will require deeper understanding regarding the topic. And let's get started with question number 1. So right now we have y is equals to kx squared minus 4x plus 3k. And they want us in this form, which is essentially we need to complete the square. So right now what we need to do is we need to force k out, because during completing the square we can't have any other coefficient in front of x squared except for 1. So right now what we have is y is equal to k x squared minus 4x by k plus 3k. And like common practice, we leave the c, we do not touch the c. So y is equals to k x minus 2 by k square minus 2 by k square plus 3k. But notice something. Since we took out k as a common factor before, not common, but we force it out since we can't have a coefficient except for 1 in front of x squared. Up to the second term, we force k out. So we need to put a bracket here, which shows that we did this before. It's an essential step. In order to avoid confusion for you as well as the examiner. So right now, what we're doing is we're gonna distribute it in. So we have y is equals to k x minus 2 by k square minus 4 by k plus 3k. 4 by k because 2 by k square is 4 by k square, and 4 by k square multiplied by k is 4 by k. So right now, rearranging the question a little bit, we have y is equals to k x minus 2 by k square plus 3k minus 4 by k. So we already answered the first part of the question, and hence we need to find the second part of the question. The question asks, hence find the value of k if the maximum value of y is 4. So right now what we need to understand is that since it's a maximum point, the graph would look something like this. This is a very rough sketch. I did not take into account the equation at all, but since it is a maximum point, what we need to understand is that the k will be negative. Because if the k is positive, then we will have a smiling curve, as I would like to call it. That's one thing to take into account already before we solve it further. And so in order to solve for the turning point, we know that the turning point is x, comma 4, because 4 is the maximum value already. In order to solve for this x, we take this one, x minus 2 by k is equal to 0. So we can find for x, which is x is equals to 2 by k. So even though we solved that, we found out that x is equals to 2 by k, and this is in terms of k, doesn't really help us solve the problem, because the information that they gave us was the maximum value of y is 4. Yes, we can use that, but that will give us a longer solution or a longer working. Right now, if you realize, I have highlighted it, that 3k minus 4 by k is actually the value for y, in the turning point. So this is actually equal to 4. So we have 3k minus 4 by k is equal to 4. And multiplying everything by k to get rid of the denominator, we have 3k squared minus 4 equals to 4k. So we have 3k squared minus 4k minus 4 is equal to 0. And right now, as you can see, we can factor it out. So we have 3k, k, 2. You can use the quadratic formula as well if you like. So we have 6k and 2k. And since we want a negative value, we have negative 6 and positive 2, which will give us negative 4k. So this one is positive and this one is negative. Yeah. So if 3k plus 2 and k minus 2 is equal to 0. So we have two solutions. Yeah. We have k equals to 2 and 3k. Wait, we have k is equal to negative 2 by 3. So yeah, right now if you put in two solutions into your answer, you will not gain full marks. You will lose the final mark in your working, because if you realize, like what I said just now, yeah, k will always be negative because it is a maximum point. Yeah, since k is the coefficient in front of x squared, and that determines whether the function will have a maximum point or will have a minimum point. It's very crucial to know that in this question right here, the correct answer will be k equals to negative 2 by 3. Yeah, so, and then hence k equals to 2 will be not applicable. Yeah, and that's it for question number 1. Moving on to question number 2. Okay, so for question number 2, we have here that k minus 6x squared minus 8x plus k cuts the y-axis at 2 points and has a minimum point. Find the range of values of k. Yeah, this one has a similar concept to the previous question, in which we are talking about either a maximum or minimum point. And so here we can say that k minus 6 must be greater than 0. Yeah, it can't be 0 because we can't have it greater than or equal to 0, because yeah, the coefficient in front of x squared can't be 0. It must be a non-zero number. Yeah, so here we need to take into account that k minus 6 will always be greater than 0. And another thing to take note of as well is that it cuts the y-axis at 2 points. This means that the roots are real and distinct. Yeah, distinct in a sense that they are different. Yeah, take an example of x plus 2 squared. Yeah, this, if we expand it, we have x squared plus 4x plus 4, and hence the solution for this equation is x equals to negative 2. Yeah, so it's real, but it's not distinct. Yeah, take note of that. So with that being said, let's actually move on to solving the equation. So right now what we can say is that since we have declared that it's real and it's distinct, we have b squared minus 4ac will obviously be greater than 0. Yeah, so from here on, it's pretty straightforward. We have negative 8 squared minus 4, k minus 6, yeah, and k is greater than 0. Yeah, so we have 64 minus 4k squared plus 24k will be greater than 0. Yeah, so we have negative 4k squared plus 24k plus 64 will give us greater than 0. So if you realize, we can take out 4. Yeah, we can divide everything by 4. So we have negative k squared plus 6k plus 16 is greater than 0. Yeah, but notice here that the coefficient of k squared is negative. Yeah, it's a negative sign. And to ease out the process of factorization, I've decided to times everything by negative 1. So right now we have k squared minus 6k minus 16 would be lesser than 0. Yeah, realize that if we flip the sign, yeah, we will need to flip the inequality sign as well. Yeah, we flip, since we times everything by negative 1, we must flip the inequality sign. So right now if we factor it out, we have k minus 8 times by k plus 2 is lesser than 0. Yeah, and first, like what I said in the previous video, we declared that it is equal to 0. So we have k minus 8 and k plus 2 is equal to 0. Yeah? So k is equal to 8 and k is equal to negative 2. So right now if we draw the number line, we have negative 2, we have 8. Yeah, and let's just test for a random variable that is not its root, random number that is not its root, so we can try for 0. So 0 squared minus 6 times 0 minus 16 is a negative number. And since 0 is in between negative 2 and 8, we would say that this one is negative, this one is positive, and this one is positive. Yep, so what we have right now is negative 2, k, 8. Yeah, so k is greater than negative 2, but less than 8. Now if we leave it at here, we're partially correct. Yeah, we solved the fact that it intersects the x-axis as 2 points, so the determinant is greater than 0, and the determinant is greater than 0. But we forgot to, but if you do that, it means that you forgot to take into account that it has a minimum point. And like I said earlier on in this video, if a function has a minimum point, that means that the coefficient in front of x squared must be positive. Yeah, it must be greater than 0. And since the coefficient in front of x squared is k minus 6, yeah, the minimum value that k needs to have must be greater than 6. Yeah, because 6 minus 6 is 0. Yeah, that is still not greater than 0. So the minimum value is greater than 6. Yeah, so the final answer would be negative 6 k 8. Yeah, or in other words, k is greater. This should be positive. My bad. So k must be greater than 6 but less than 8. Yeah. Realize how we adjust the equation, but it still fits because the range originally was k is greater than negative 2 but less than 8. Yeah, we have kept the upper bound, which was 8, but the lower bound we have increased because negative 2 minus 6 will give us negative 8. And if the coefficient of x squared is negative, like what I said before, it will not give you a minimum point, it will give you a maximum point. Yeah, so we readjusted the inequality. So right now the range of values for k, which is true for both of the aspects that was asked in the question, will be k is greater than 6 but less than 8. Yep, so this is solved. Moving on to question number 3. Okay, so for question number 3, yeah, so far, if you have realized, the questions that I've chosen it does still test out your mathematical skills, but it also tests out the understanding of the concepts you have learned. Yeah, if you realize I have placed in multiple concepts into one question, and you need to understand the concepts properly so you can readjust or manipulate your final answer to suit the criteria that the questions have set. And this is exactly what what question number 3 is testing as well. So here we have what value of m makes the expression 2m minus 1x squared minus 4 open bracket m minus 2x plus m minus 1 a perfect square. Yeah. So right now we see here that we are also going to use the determinant, but let me just say what makes a function a perfect square. Yeah, a perfect square function is just like what I said earlier on. Take an example of x squared plus 4x plus 4. If we factor it out, that will give us x plus 2 square. Yeah, the fact that it has x plus 2, it only has one root. It's not distinct, but it's a real root. Yeah? It's a real root, but it's not distinct. Yeah? That's what makes it a perfect square. Yeah? So this is what the question wants us to find for what value of m is the expression a perfect square. So right now what we can directly say is that b squared minus 4ac, or the determinant, must be equal to 0. Yeah? So right now what we have is negative 4m plus 8. Yeah? I just distributed negative 4m into the brackets. Square minus 4, 2m minus 1, and c is m minus 1, b equal to 0. Yeah? So we have 16m squared plus 64m, minus 64m plus 64 minus 4 open bracket 2m squared, yeah, minus 2m minus m plus 1 will give us 0. Yeah. So if we further simplify the equation, we have 16m squared minus 64m plus 64 minus 8m squared plus 8m plus 4m minus 4 is equal to 0. Yeah. And if we further simplify it again, 16m squared minus 64m plus 64 minus 8m squared, yeah, and plus 12m minus 4 is equal to 0. Yeah. So right now what we have is 8m squared minus 52m plus 60 is equal to 0. And if you realize everything, we can divide it by 4. Yeah, it has a common factor of 4. So we have 2m squared minus for 13m, yeah, plus 15 is equal to 0. Yeah. So right now we can factor it out again. So we have 2m, and I'm here. We have 5. We have 5 here, and we have 3 here. So we have 10m and 3m. And to make it negative 13, we have negative 3 at negative 10, so we have negative 13m. That will give us 2m minus 3 and 2m minus 5. Yeah. So we have 2m minus 3 into m minus 5. And that will give us equal to 0. Yeah. So right here we can say m is equals to 3 by 2 and m is equal to 5. Yep. Okay guys, that's it for quadratic expression and equations. I hope you guys found the video useful, and I hope you guys found the questions challenging but also interesting to do. I hope that you guys, after watching the solution, you guys will also try it out, or even better, you actually try it out before looking at the solution. And that will be best for your understanding as well. And yeah, I will see you guys in the next video, and the next video will be about polynomials. Okay? Bye, and thank you for watching.